Hey everyone, today we're going to talk about how to graph an absolute value function, how to graph a piecewise function, and how to write an absolute value as a piecewise function. Absolute value functions we've talked a lot about. So let's find the vertex of the absolute value. To do that, we set the inside equal to 0 and solve, and then to find the y value, we plug the x back into the problem and solve. So the first thing I'm going to do is find the vertex. Set the inside equal to 0 and solve, plug that back into the problem and solve. Plot the vertex on the graph. Pick an x value from either side of the vertex. Once you find the x values, plug them back into the equation to find the y. So you're finding 2 more points. Plot each point on the graph and make the v-graph. If it's an inequality, determine the line and shading. If it's not equal, it's a dotted line. If it is equal, it's a solid line. Greater than, we shade above. Less than, we shade below. Let's take a look at some of these. Add 2 absolute value x plus 4 minus 3. So let's find the vertex. What number would make the inside equal 0? Negative 4. If you plug negative 4 back in, you get 0 times 2, which is 0, minus 3. So a vertex is negative 4, negative 3. Pick a point on either side. How about I pick negative 3 and negative 5? Plug those in and get the y values. Negative 3 plus 4 is 1. 1 times 2 is 2. 2 minus 3 is negative 1. So negative 3, negative 1. Plug in negative 5. Negative 5 plus 4 is negative 1. Absolute value is 1. Times 2 is 2. 2 minus 3 is negative 1. Negative 5, negative 1. Draw your v. And it's that easy. On a quiz or test, I'm going to look for the vertex, I'm going to look for your other points. Let's take a look at this one. This one's an inequality. What's my vertex going to be? Well, what makes the inside 0? 6. If you plug in 6, you get 0 plus 3, you get 3. So 6, 3 is a point on this graph. It's the vertex. So 6, 3. Let's pick a point on either side. If you plug in 5, 5 minus 6 is negative 1. Absolute value is 1 plus 3 is 4. 7 minus 6 is 1 plus 3 is 4. So 5, 4, and 7, 4. Now, is this a solid line or a dotted line? It's equal to, so it's a solid line. Now, it's less than, so which way do I shade? I shade below. Less than means shade below. And that's my graph. Let's take a look at this one. What number would make the inside 0? Negative 7. If you plug negative 7 back in, you get negative 4. So negative 7, negative 4. Pick a point on either side. If you plug in negative 6, you would get 1. Times negative 2 is negative 4, or times negative 2 is negative 2. Negative 2 minus 4 is negative 6. So negative 6, negative 6. If you plug in negative 8, you get negative 1. Bars makes it 1. Negative 2, negative 6. Solid line or dotted line for this v? It's not equal, so dotted line. Shade above or below? It's greater than, so we shade above. Piecewise functions. A piecewise function is a function that is a combination of 2 different functions hooked together at some point. Sometimes these functions match up, I should say match up, and you have a continuous function. Other times they miss each other and there's a discontinuity. Here's an example of a piecewise function. Where do these 2 things hook together? They hook together at 0. One side, the left side, is this line, 2x plus 3. The right side is a parabola, x squared plus 4. And you can see 2x plus 3, and then the parabola x squared plus 4. They missed each other, but that's okay. That's a discontinuity. So a piecewise function is 2 different functions hooked together. How do I write absolute value as a piecewise function? Absolute value is a great example of a piecewise function. The V shape comes from the fact that there are two lines to the problem. Therefore, each side of the V is really a line that meets at the vertex. Take a look at this. The vertex is 2, 3. There's the vertex. The two lines are x plus 1 on the right side of 2 and negative x plus 5 on the left side of 2. How did I know it's split at 2? Because my vertex's x value is 2. Now how do I write those? Determine the x value of the vertex. That's where the graph will split. Write two linear functions. For the first, turn the absolute value bars into parentheses and simplify. For the second, turn the absolute value into parentheses and negate and then simplify. Determine the general shape. Does it open up or down? Determine which function goes first. If it goes down then up, then negative slope comes first. If it goes up then down, then positive slope comes first. So let's write this as a piecewise function. The first thing is I need to know what the vertex is. In this case, the vertex is 3, 7. So when I go to write my piecewise function, I'm splitting at 3. Now one of those has to be equal. Doesn't matter which one, whatever makes you happy. Now it says to write one function with no bars, just parentheses, and simplify. So that's 2x minus 6 plus 7 is 1. The other one is going to be, now negate everything inside. So that's negative 2x plus 13. So one of these equations is going to be 2x plus 1. The other equation is going to be negative 2x plus 13. But I need to figure out what this graph looks like. Well, it's a positive V, so it looks like this, which means that the negative side is first, and the positive side is second. So I'm going to write the negative slope first. The negative slope was negative 2x plus 13. And then I'm going to write the positive slope second, 2x plus 1. And that's my piecewise function. How do I graph a piecewise function? I'm going to figure out where the function overlaps, and that's where I look at the domains. I'm going to make a table and I repeat the overlapping numbers. I determine which one is a dot and which is an open circle. Determine which part of the table goes with each equation. Colored pencils help here. I use my colored markers. Plug the x values into the correct function to get the y values. So I'm going to make a table and sketch your function. And they don't have to meet. So let's sketch this. Well, where do those two functions overlap at? They overlap at 1. So when I make my table, I'm going to write 1 twice. So I'm going to get a few more points. Negative 1, 0, 1, 1, 2, and 3. This guy is for the numbers less than 1. So I'm going to plug in the numbers less than 1 here. So negative 1 gives me 3 plus 2, that's 5. 0 is 2. And 1 is negative 1. So I have 3 points. This function goes with the numbers greater than 1. So I plug in 1, I get negative 1. Plug in 2, I get 2. Plug in 3, I get 7. Now I need to figure out which one's a solid dot in an open circle. The first one is equal to, so it's a solid dot. The second one is not equal to, so it's an open circle. So let's draw the first one. Negative 1, 5. 0, 2. 1, negative 1. Hey, look, that's a line. The next one, 1, negative 1. Oh, look, they meet up. 2, 2. 3, 7. Look, that's a parabola. And there's my piecewise function. This one's continuous because where this one ends, that one starts. Okay? If you guys have any questions with this, please come talk to me. We'll work through some more piecewise functions in class. Other than that, thank you very much.